Today in class we learned about inscribed angles. So far we've learned what a central angle is, and a central angle is any angle in a circle where the vertex is at the center. An inscribed angle, the type of angle that we learned about today, has its vertex on the circle and looks something like this. So there are a few relationships formed. Between these two angles. So an inscribed angle is always going to be half the measure of the central angle. Or if you are given the inscribed angle, you can just multiply it by 2 in order to get the central angle. So therefore, we can make a general rule for inscribed angles and central angles. Where if the inscribed angle is A, the central angle is going to be 2A. Okay? And the way you can know this, if they give you a problem and you're supposed to solve, let's say they give you the measure of the inscribed angle and you're supposed to solve for the central angle, you know that the inscribed angle always has to be smaller than the central angle. So you'll know that you would have to multiply this by 2 in order to get the central angle. Why is the inscribed angle always smaller than the central angle? Think about a circle. This is the central angle. This is an inscribed angle. This is an angle that's all the way out here. If you'll notice, as the vertex of the angle moves away from the center of the circle, the angle gets smaller and smaller. So know that the inscribed angle always has to be smaller than the measure of the central angle. So that's the first type of problem that we'll deal with. The next type of relationship that's created by inscribed angles is when the measure of two inscribed angles are supported in the same arc. So when two inscribed angles are supported in the same arc, it creates two congruent angles. So let's draw our first inscribed angle. It's going to go right here. And this is the arc that it supports. Okay? Now let's draw our second inscribed angle over here. And this becomes the arc that it supports. So notice that they support the same arc. If you have two inscribed angles that support the same arc, their angle measures are congruent. Okay? Another relationship that occurs with inscribed angles is when an angle is inscribed in a semicircle. So picture a semicircle. It's cut in half by a diameter. So the measure of the central angle of a diameter is 180 degrees. If we draw an inscribed angle, the measure of an inscribed angle is half the measure of the arc that it intersects. So we know that this angle has to equal 90 degrees. And this is true for any triangle inscribed in a semicircle. It's always going to be 90 degrees. The last relationship we're going to look at is when a quadrilateral is inscribed in a circle. Okay? So let's say we have this shape inscribed in a circle. In a circle, the angles opposite one another in a quadrilateral, when added together, equal 180 degrees. Okay? All right. So knowing this, we're going to move on to a few example problems. So in this one it says, the inscribed angle is supported in the diameter, and its measure is 3x plus 33. Find the value of the angle. So first I'm going to draw a circle, and then it says the inscribed angle is supported in the diameter, so I'm going to draw a diameter next. We know that the measure of diameter central angles is 180. We'll draw the inscribed angle up here with its vertex on the circle. We know that the angle across, that the angle in a semicircle is always going to make it a right triangle. So this is 90 degrees. So the question tells us that the measure is 3x plus 33 of this angle. So we said equal to 90 to solve for x. We get 3x equals 57. X equals 19. Now, we're not finished here because it says find the real value of the angle. So you can either just substitute 19 back into the original problem and get 90. Or you can just show that you already knew this angle equaled 90 and that's how you solved for x. Okay? So two different ways. But the answer is 90 degrees. And number 2 on page 163, it says two inscribed angles are supported in the same arc. So remember, for this type of problem, two inscribed angles supported in the same arc, we're going to draw one inscribed angle here, one inscribed angle over here, and we end up with that picture that looks like two strange triangles, okay? Let's label them A and B. Find the values of each A and B if they are A, 3x plus 4, and B, x plus 18. Okay, well we know that two inscribed angles supported in the same arc create two congruent angles. So this angle is congruent to this angle. If we are given the algebraic representation of each angle, we can set them equal to each other in order to solve for x. And we get x equals 7. Are we finished? No, because it says find the values of each of them, okay? So to find the value of A, we know that A is 3x plus 4. You know that x is 7, so 3 times 7 plus 4. You get 21 plus 4, you get 25. Angle B is x plus 18. X is 7 plus 18 is 25. And they are both equal in measure, as we knew earlier. So I inscribed a quadrilateral in the circle. The measure of angle W is 95, and the measure of angle Z is 60. Quadrilaterals inscribed in a circle, when you add the angles across from one another, they equal 180 degrees. So if we're trying to find angle X, we know that angle X plus 60 has to equal 180 degrees. So you subtract 60 from both sides and you get X equals 120. So angle X is 120 degrees. If we're trying to find angle Y plus 95 degrees is 180 degrees. Minus 95, minus 95. Angle Y equals 85 degrees.
So,
and that's it.